Welcome to The Explainer. Today, we're going to cut through all the noise and get straight to the core science of what's happening to our planet. So let's talk about its rising fever.
So let's just jump right in with a pretty simple question. Is the Earth actually running a fever? And the answer really starts to take shape when we look up into our atmosphere.
Okay, so first things first, what do we even mean by climate change? This isn't just about one really hot summer or a weirdly warm winter. No, we're talking about these big, long-term shifts in our planet's temperature and weather patterns. And these shifts have been hitting fast forward since the 1800s.
So what's actually causing this? What's the engine behind the change? Well, it all comes down to something you've probably heard of, the greenhouse effect. But what is that, really? This is the perfect way to picture it. Seriously, think of our atmosphere like the glass roof of a greenhouse. Sunlight streams in, warms up the planet, and then, as that heat tries to escape, some of it gets trapped by certain gases. It's like a big, invisible blanket keeping us warm. But here's the thing, and this is super important. The greenhouse effect isn't naturally a bad guy. In fact, it's the hero of our story. That natural blanket is exactly what makes our planet livable in the first place.
And this right here shows you the whole story in one image. On the left, you've got that natural balance, the Goldilocks zone that keeps Earth at a pretty comfy 15 degrees Celsius. But then, look at the right. That's the enhanced effect. That's us, through our activities, basically throwing another, much thicker blanket on the planet. And, well, it's tipping the scales.
To really drive that home, without that natural blanket, what would the Earth's average temperature be? A mind-numbing minus 17 degrees Celsius. Absolutely freezing. We wouldn't be here. So the problem isn't the effect itself, it's that we keep making the blanket thicker and thicker.
Okay, so what exactly is making this blanket thicker? Let's meet the main gases responsible for all this extra heat. Now, there are a bunch of different gases that contribute, but we're going to zero in on the two heavy hitters, the main characters in this human-caused part of the story, carbon dioxide and methane. And I love this analogy. Think of these two like runners in a race. Carbon dioxide, or CO2, that's your marathon runner. It has incredible staying power. It hangs out in the atmosphere for centuries, just slowly and steadily adding to the warming. Then you've got methane, CH4. That's your sprinter. It's an absolute beast in the short term, trapping over 80 times more heat than CO2 over 20 years, but it burns out and breaks down much faster. So where's all this stuff coming from? Well, this table breaks it down pretty clearly. For CO2, the big sources are exactly what you think. Burning fossil fuels, coal, oil, and gas for basically everything, plus things like deforestation. For methane, it's a bit different. A lot of it comes from agriculture, think rice paddies and livestock, but also from landfills and pulling fossil fuels out of the ground. And what's the upshot of all these extra gases? Well, it's already had a very real measurable effect. The planet's average temperature has already climbed by about 1 degree Celsius since the late 1800s. And that warming is tied directly to how much of this gas is up there. Get this. In 2023, the average concentration of CO2 in the atmosphere hit over 421 parts per million. That's the highest it's been in at least 800,000 years, way, way before humans even showed up on the scene. Now, I know what you might be thinking, 1 degree? That doesn't sound like a lot, right? But for a whole planet, it's a huge deal. It's like a person running a fever. So let's look at the symptoms that are showing up all over the globe. And how do we know this isn't just normal? Well, it's because nature keeps its own receipts. It's incredible. Scientists can literally read our climate's history books, and they're locked away in things like tree rings and deep inside ancient glaciers. And these records are screaming one thing. The planet's climate has changed before, sure, but never this fast. So what are we seeing on land? Well, that extra heat is turning up the dial on everything. More intense heat waves, more often, a much higher risk of devastating wildfires. And we're seeing our planet's ice, what scientists call the cryosphere, just shrinking. Glaciers, polar ice, it's melting at an alarming rate.
And it's not just on land. The oceans are feeling it big time. All that melting ice, plus the simple fact that water expands when it gets warmer, means sea levels are on the rise. And that's not all. The heat is fueling stronger storms and causing heartbreaking events like mass coral bleaching, which basically wipes out entire underwater ecosystems.
And let's circle back to our sprinter, methane. This quote really puts its impact into perspective. Even though it doesn't stick around as long, right now it's responsible for nearly half of the net warming we're experiencing.
That's huge. So, okay, we've looked at the how, the what, and the why. What's the big takeaway here?
It's pretty simple, really. The science is crystal clear on this. Human activity is turning up the planet's thermostat. The stable climate system that we have built our entire world around, it's changing, and we're the ones changing it.
So, the story the science tells is one of cause and effect. We can see the chain of events, from the emissions we create to the fever our planet is running. The data gives us the what and the how, but it leaves us with the biggest question of all, one that goes way beyond the science. So, what do we do next?